talk to my computer. Mostly unfriendly things about my computer.
I thought you were all about pandering to the future robot
Well,
overlords.
that is always a concern, but obviously emotions get the best of me.
Fair.
Yeah.
I mean, I talk to my cats. Does that count? Because I
Yeah.
do that a lot.
That
Well,
sounds pretty normal.
Okay.
well,
Thanks for the support. I appreciate that.
no, no. Well, we have a deaf dog, so it's pointless.
So
Yeah, when you like
maybe
talk to
maybe
your
he
dog.
can lip read.
Yeah, yeah. You talk to your dog, and no, I mean she's not looking at you, but all that just like that the jabbering that we do to our animals, none of it they don't pay. None of it they pay any attention to.
Hmm.
It just really gets displayed in stark reality when you are talking to a deaf dog. That as long as it's like not looking at your face, it can't see anything. So, say hi to me, everybody. And us, say
Hello.
hi to us, and
It's
then I will say
us.
hi back to everybody. Um, we've got no Paul and no Morgan this week,
Yeah.
and no Pamela. She's traveling, and Brian Coberline is getting lined up. Maybe next week, I hope.
That'd
He
be
will be
cool.
our astrophysicist replacement for Paul.
Where is Pamela?
She's off to somewhere in Europe for
Everyone's
something.
having fun vacations. But
I don't think it's a fun vacation.
Morgan's in Australia right now.
Yeah, no, that's a fun vacation.
Scuba diving on the reef.
Yeah.
Jealous.
Hello to Anti-Gravity Nonsense, Bill Sugden, Christian Woodland, Colin Jones, David Dunn, David Fairweather, George Lancaster, Giselle Sabrin, Johnny J, Kim Barron, Larry Beckham, Martin Bradshaw, Nancy Graziano, Paranora, Peter Wolsk, PsychoCat749, R. Instro, Rick Schwartz, Robert Shaw, Roger Haskins, Scott Bragdon, Sergio Botero, Sergusi, Terry Eyes Anderson, Tom Van Scotter, Von Lichtenbutz, and Zappan Zappan. Hey, everybody. Welcome to this slim down version of the Weekly Space Hangout. But we have done a whole hour with absolutely no agenda and had a party. So I think
That's true.
we can
You and I had a great time.
Yeah, we could pull this off.
Chatted about all sorts of stuff.
Yeah,
and I have enough personality for cover everyone
yeah,
else.
no, absolutely. It's pronounced Wolski. All right. Thanks, Peter. Nico D. Budapest. There you go. FN remembered. Johnny J wonders if Paul is not coming back. No, Paul is coming back. Paul is just doing about 1 million things simultaneously. He is trying to fit us in between now and the end of the calendar year, but it's like he's got the All-Stars Star Party. He's got this dance troupe that he's a part of, which they're traveling around doing performances. He's doing a book tour. And there's something else that's taking up his time. Anyway, so yeah.
I think what it boils down to is that Pamela and Paul and Morgan all lead more interesting lives than I do.
Oh, I think that, but they're not getting the same kind of productivity.
That's true.
As you are being able to work from.
Oh, Fraser,
home.
my wild strawberries came in again this year.
Oh,
They're
good.
all over the place.
Oh, nice. Like the little guys.
Little itty bitty ones. They're like this big, and
yeah.
they're like strewn all over my front and backyards.
You can feast from those all the way through into really late season. Like they'll be whenever it freezes over there we can get them here in December.
Never freezes.
Oh, well,
just
there you go.
Slushy.
Yeah, well there you go. So you can get them late into the year, which is great. They're one of my favorites, and they're so tasty.
They are pretty awesome.
These little tiny little strawberries. Yeah, we actually see them hiking out in the wilderness too.
Yeah, now that I know what they are, I see them everywhere. It's like when you buy a new car.
We had a
everywhere.
We went for a hike on Sunday, and we had it was a 3-tick walk. So 2 ticks for Carla and 1 tick for the dog. So, yeah, it's that season.
Sorry about the cat cameo.
No problem. That's the best. All right, let's get it started. To me, here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, May 8th, 2019. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about confirming a 2,000-year-old nova observation. 2024, moon. Is it going to happen? Haumeia's ring, the Hubble Legacy Survey, gold from neutron stars. Joining me this week, we've got Dr. Kimberly Cartier. That's it.
Hey, Fraser, happy podcast day. It's the Kim and Fraser podcast.
We can pull it off.
Week.
It's been the Morgan and Fraser show. We can do the Kim and Fraser show. No problem.
We have a great time when it's just the two of us
we've
on a podcast.
done this in the past. No problem.
There's
Everyone's
enough
going to have a
space
good
for
time.
everyone.
But definitely get all of your
Space.
cool exoplanet questions queued up for Kimberly, and then I'll just...
I don't have an exoplanet story this week,
No.
but still ask me all the questions.
Yeah.
I
People
love
have
'em.
some questions for you. It's not like anything new was discovered like in the last week that I saw. Wait. No, I can't
Maybe.
think of any big stories that came out.
There's probably like 100 exoplanets though, so
Yeah.
let's be real.
Yeah, that were found or confirmed. All right. So before we get into our special guest, who's waiting patiently, I want to give a big shout out, as always, to our good friends at the Weekly Space Hangout crew. This is, of course, the community, the fans, our friends. They are the ones who coordinate the special guests, such as today. And so if you want to be a part of this great community, go to wshcrew.space and they will hook you up. You'll get a chance. You can talk about stuff down in the chat here while we do our live shows. But more importantly, you will become an executive producer of the show immediately for free, and we will put you to work. So finding the kinds of guests who you want to have here on the show. All right, speaking of guests, let's get into it. Our guest today is Dr. Henry Shea from the Planetary Science Institute. Henry, welcome to the Weekly Space Hangout.
Hi, thanks, Fraser. Thanks for having me.
Where are you located? Are you in the middle of the country?
I'm in Hawaii.
You're in
actually.
Hawaii. Oh, wow. Okay.
Yeah.
Oh,
So Planetary Science Institute is in Tucson, as you might know, but I'm one of the many remote people. So I've set up shop in the middle of the Pacific.
yeah, you can't go wrong there. Are you on the Big Island or?
I'm on Oahu.
You're
in
on Oahu.
Honolulu.
Okay, that's awesome. I was just there. Well, I was on the Big Island just a couple of months ago. It's so great there. So what do you do?
So I do lots of things. By training, I started out as an observer, so I use telescopes a lot. So kind of how I got started, especially in Hawaii with all the great telescopes we have here. And I've continued to do that, but since then have sort of gotten interested in things like surveys for finding interesting things in our solar system, and also some kind of more on the computer side, computational stuff, doing dynamical simulations of see how things move around in our solar system. So sort of a mixed bag, but generally asteroids and comets are sort of my interest.
And the research that I think we covered here in the Weekly Space Hangout, it was back at sort of at the end of March, early April, was this super weird asteroid that had like a comet-like tail that was seen, and there were some really beautiful images shared by the Hubble Space Telescope. And I'm just going to put this up on the screen so people can see the picture, and they probably remember this story, asteroid 6478 Galt. So you were one of the people who worked on this photo and on this asteroid research. What's interesting about it?
So the interesting thing is that it orbits in the main asteroid belt. So has a pretty circular orbit, pretty flat relative to the planet solar system. And this is very unlike other comets, like Halley's, the most famous one, of course. But most other comets have more elongated orbits, often very tilted. So this is right smack in the middle of all the other asteroids that are just kind of rocks that are just, as far as we can tell, just happily orbiting circularly around the sun. Yet it shows this morphology, this appearance that makes it look like a comet, which is, when it was first, when these types of objects were first observed, it was very confusing to people because they thought there was like a clear delineation between, you know, active things on these like long elongated orbits and inactive things on these circular orbits. But you know, we started to discover these things that had properties of both asteroids and comets.
So it's, I mean, I can just imagine how weird and surprising this was, that we imagine the asteroid belt, and of course, like Star Wars has taught us everything we need to know about the asteroid belt. But you imagine rocks. We've seen some great close-up pictures, like from Hayabusa and you know, asteroid Bennu and things like that. Rocks, and they're all tumbling around in this region in the solar system. But you've got this one that's got this bizarre tail, and I mean, when you look at the picture, it's not only the one tail. I mean, just like a comet, it's got that secondary tail as well, and that comes from like two different kinds of volatiles coming off the comet, right?
Well, actually, in Galt's case, Galt is actually not, the activity is not powered by volatiles at all, we think. So that's been the interesting thing over the last several years, that, originally we thought that, originally we thought these things were separate. And then we found a couple that were exhibiting activity that we thought was due to volatiles. Galt is a different kind of active asteroid where the activity we think is due to its fast rotation. So, so this is actually material that's being flung off the asteroid. And so the two tails are actually the result of two different events where material is flung off the asteroid. So the analogy is like if you imagine like a sand pile, and you'll have like a landslide that, like, you know, you pile more and more sand on top of it, and then at some point it gets to the point where just a bunch of sand just flies off. And on an asteroid where there's no or very little gravity, that stuff flies off into space. And so so what we think is happening on Galt is that you have two of these kind of landslide events, two distinct landslide events that's causing these two tails that happen at different times.
And so these happen at two different times, and then it's just taking time for the debris to sort of trail behind the asteroid.
Yeah, exactly.
And that is it interacting with the solar wind.
Right. Yeah, exactly.
Right. Okay.
Yeah.
And so then is this kind of thing happening on a regular basis? Like if you looked at it again a year from now, would you see something different? Or is this the kind of thing, like, I'm just trying to think, like, would you see this across many different asteroids at various times? Would all asteroids at some time have an event like this? Or does this asteroid do this all the time because it's spinning so rapidly?
Yeah. So all those are great questions, and that's like exactly what people are asking actually right now. So the question of whether this will happen again. So there was actually just another paper that came out very recently where someone looked back at old images of the asteroid. And so these were serendipitous images, so they weren't specifically targeting this object because they didn't know it was interesting. But they found actually it has had a tail in the past, like 2-3 years ago or something. I forget offhand. But yeah, it seems like it's been kind of rotating at this kind of fast, a little bit too fast for its own good, so to speak. And then material's been kind of just like sloughing off every once in a while. There's another object that had a similar behavior, discovered in 2013. And that has not been seen to, so that also showed like kind of multiple tails that we think was due to rotation. But that has not been seen to reactivate. So, I mean, we've got 2 examples of these objects now, and 2 is a very small number. So we really don't know. We haven't been studying them for that long.
I mean, it's tough to get time on the Hubble Space Telescope. I hear that telescope is busy. So I mean, it's not like you can just do nonstop continuous observations of this object for years, using up all the Hubble time. So I mean, do you have other ways that you can get at this data and be able to look at it?
Yes. Well, so the Hubble is great for getting like really detailed images of things that we've already identified are interesting. But you're right, you can't just search random asteroids, most of which will be, just rocks. So it won't be very interesting. So that's where these surveys come in. So these are, telescopes that basically are scanning the whole sky all the time. There's one in Hawaii called Pan-STARRS. So that's the one that discovered many of these objects. The one that discovered Gault is called Atlas. That's also in Hawaii. And then soon we'll be getting the Large Synoptic Survey Telescope, which is a really long tongue twister of a name, also known as LSST. So that will scan the whole sky all the time, or not the whole sky as visible from its location all the time. And, every so often we'll spot, one of these things that's like point of light, but slightly fuzzy.
Oh, okay.
And then we'll go target that with like a slightly, with like a ground-based telescope. And then if it's interesting enough, then we'll call in Hubble and have them take a shot. So it's sort of like a, funneling towards the most interesting objects.
Well, yeah. I know that the distinction between what's an asteroid and what's a comet has gotten a lot blurrier over the last couple of years. We're seeing comets with very asteroid-like sort of parts to it, and comets, asteroids that behave like comets that behave like asteroids. It's a mixed up, crazy world. Where are we at now with this?
That's about right. Yeah, it's a crazy mixed up world. We have, you're right. Like, so we have spacecraft that have flown by comets, and we see them, actually look a lot like regular asteroids. They have, surface features that, look very asteroidal, things that look like craters. It's not just, just gushing gas. It's mostly, just kind of rock and dusty material. And now we have these asteroids which are showing activity. And actually, you mentioned Bennu earlier. Actually, when the OSIRIS-REx spacecraft is currently in orbit around it, they actually saw material coming off of Bennu.
Yeah, that's right.
Which was so that's like up close and personal evidence that we really don't understand the differences between these things. And maybe there's no difference between the two different classes, and they're not two different classes. They're just sort of a continuum of things that have different dynamical and physical properties.
And before we start on the show, you were talking a bit about some, considering how objects might be migrating through the solar system, even to this day. Did you want to talk a bit about that? So to kind of step back, so comets, like I said, have these sort of elongated orbits, and that's because we think that they mostly originated in the outer solar system. So they came from like the Kuiper Belt or the Oort cloud, and then they kind of, for whatever reason, they got knocked into the inner solar system, and then and are now orbiting, within, sight distance from the Earth. But yeah, so these have sort of very distinctive orbits. And so we thought, anything with this kind of orbit, we therefore know where it came from. And likewise, asteroids have very circular orbits. So, so if we look at it and it has a circular orbit, we sort of assume, okay, it came from the asteroid belt. It was always in the asteroid belt. But recently we've come to, there have been some studies that have shown that actually you can turn one of these elongated cometary orbits into a very circular asteroid orbit in certain circumstances, and vice versa. So, so this is something that people have sort of thought was the case, but it seemed very implausible, and it seemed easier to say, oh well, maybe these are just asteroids that are icy, and in fact, some of them, this is probably the case, but we probably have things that are, it's not just the physical properties of asteroids and comets that are, sort of blurry and sort of on a continuum, but their dynamical orbital properties as well. So, so this is a very kind of new and fast developing topic. So, the problem is that the more that we learn about these things, when we look at Itokawa and we look at Ryugu and we look at Bennu and Eros and all these, they're all different. And now what we really need is 1,000 spacecraft visiting, each one visiting a dozen asteroids to get a much better sense of the weirdness that's out there in space. We can always look forward to
tell NASA that.
Oh yeah, I believe I have at least twice.
Oh, okay.
So I'll let you know what they say. Dr. Hsieh, thank you so much for taking the time to talk with us today. Where can people find out more about what you're working on?
They can. I don't actually have a website, so actually I'm really bad with
a website,
media.
A Twitter feed, press releases from the Hubble Space Telescope.
Yeah, that might be the best way to kind of keep
sure.
Keep track of your website. I'm sure.
Okay, perfect. Yeah, follow Universe Today, and we will cover the stories as you write them. That sounds perfect. As long as you promise to give us the inside scoop. That'd be great.
Yes, absolutely.
All right. Well, thank you so much for taking the time to talk with us today.
Yep.
All right.
Sure.
Take care.
Sure. Thanks. Sure.
All right. We're going to shift gears. We're going to move into the space news.
Space news.
What do you got, Kimberly?
So I'm going to start way back in the past because I think this is a really awesome story. About 2,000 years ago, more like 2,050 years ago or so, there was a nova that went off in the globular cluster Messier 22. So there's a lot of words in there. Nova. So a nova is not like a supernova, but a white dwarf that had some extra hydrogen dumped on top of it. Didn't like it and exploded a little bit on the surface. The white dwarf is still there. This happens semi-regularly with white dwarfs that are in binary systems. The theory is that globular clusters probably have a lot of those, though we've only detected, I think 2 or 3 nova in globular clusters orbiting the Milky Way. But a little over 2,000 years ago, Chinese astronomers detected one of these. Yeah, they did.
That's crazy.
When a nova goes off, it can outshine the entirety of a globular cluster by orders of magnitude.
Okay.
So it was very visible, even without advanced telescopes. You could look up into the sky and see, hey, there's a star, where there wasn't a star anymore before, and then it goes away rather more rapidly than a supernova would. But what happens after the nova goes off is that there's left over a shell of hydrogen and other fusion products that expand outwards in a nebula, similar to a planetary nebula or a supernova remnant. It's just a nova remnant, but it's thinner and likely more faint than a supernova remnant would be. So after the nova went away 2,000 years ago, we didn't know it was there anymore. Now fast forward to this year, 2019, modern astronomers were looking for novae and were looking at globular clusters, and they detected this nova remnant, the leftover nebula shell from this 2,000-year-old nova event, using the Very Large Telescope. Yeah, doing some X-ray and radio spectroscopy to detect this nova. That makes this the oldest recorded extrasolar observation ever. How cool is that? They confirmed the ancient Chinese observation.
So it was farther than a supernova that was seen in the past?
Yeah, so this is...
I mean, you say 2,000
So this was originally recorded in... The original observation of the nova was recorded in the year 48 BCE.
Right.
So it far predates
right
most the other early observations that we have of supernova and things like that. It's the modern detection of this nova is in the same place as the Chinese observation. It's the correct brightness for having faded for this long.
And the size of the debris.
The size of it, the location, everything about it lines up with what the Chinese astronomers would have observed 2,000 years ago.
That's
which
really
is just
cool.
really neat.
I was trying to find the animation of V838 Mon, which is sort of another nova that's pulling material from a white dwarf star. People are probably fairly familiar with that, to sort of see the same. And there's like they've been gathering evidence of it for so long that it has this great animation, and I can't make it go in this show today, and I apologize.
It's okay. Maybe put the link in the chat and people can look
maybe
for it
someone
later.
can find that video, because there's just someone's posted this great animated GIF that looks like this thing is just kind of expanding away from this star, and you're like, oh, it's some kind of it's like some kind of render, but actually no, it's just that Hubble has been taking pictures for so long now that you get this.
I mean, some of these
incredible...
nova they go off. Some of them that we've detected in the Milky Way, they go off every couple of years. As maybe one star in the binary system has evolved enough and expanded far enough that it continually feeds material onto the white dwarf, and white dwarf really doesn't like that very much.
And
so you get these repeating novas going on.
It'll keep doing that until it does it for the last time,
until it gets a little bit too fed up, and then we get a type 1a supernova,
the big one.
How exciting is that? But it just every time this happens, the very rare times this happens, where we go back and we think we're so clever, we're like, hey, look, there's a nova in this globular cluster. Like, nope, wait, this was recorded 2,000 years ago. Credit where credit's due. But it makes me think of just like how many other observations and detections like this are just probably strewn through all these ancient astronomical histories.
Yeah, I mean, we know that the ancient peoples actually had a pretty careful knowledge of the night sky. They didn't have telescopes, but they did know where all the stars were, and they could identify the locations of things, and their lives really depended on this knowledge of the night sky, to know when to plant, know when the rains would return, things like that. But I just, like, I wonder, do you know which way it went? Did they find the nova remnant in the globular cluster and then calculate back and then look through the history, or did they find the history and then see
go
if they
hunting
could find
for the
an
remnant?
object? Yeah.
I think it was they found the remnant and then wanted to check and see if there were any prior observations.
Yeah.
And so came across a reference to it obliquely, and then
amazing.
Realized that everything did match up with the prior observation.
Very cool.
Which is just really cool. I feel like someone should go through a bunch of these ancient astronomical texts and almanacs and things like that and pull out all these references to
and try to dig them all
random
up.
New star in the sky this year, and then go hunting. I wanted to go that way, in that direction.
All right, so I am going to talk briefly about the latest version of the Hubble Deep Field. And of course, if you're familiar, the Hubble Deep Field is, of course, this wonderful series of images that they've done with the Hubble Space Telescope to peer at this one specific little region of space. And there's sort of two areas that they've done this that were largely devoid of galaxies from ground-based observations. One is in the constellation of Ursa Major, and the other is in the constellation of Fornax. And so the first one was in Ursa Major, and they peered at this space that was thought to be empty, and what do you know, Hubble turns up 3,000 galaxies in this region, able to look back to about 13-ish billion years ago and see these galaxies doing their thing in ancient times. And then they do this second version where, after they did this upgrade on the Hubble Space Telescope, they were able to do this another version of it, but now they had the advanced camera for surveys. It was 10 times more sensitive, and they were able to shoot in this different area in Fornax and go even closer, literally, to the beginning of the universe. But their observations were like 1 million seconds, something like, I forget the number, 12 straight days of observations over multiple orbits, all just in this one area, just again and again and again. And so then they followed that up with another survey, an infrared survey, which is another instrument on board called NICMOS on the Hubble Space Telescope. did that in the infrared spectrum, and then they were able to gather all those images together into one large image, and that's called the Hubble Extreme Deep Field. I love that. You got the Hubble Deep Field, you got the Ultra Deep Field, and you got the Extreme Deep Field. Well, this week, Hubble released
Is it the very ultra extreme
no,
field?
no, it's called the Legacy Deep Field.
Oh,
Yeah. And
okay.
I'll show people the.
I suppose that's a more dignified name.
Yeah, exactly. You can see the picture here. So the Legacy Deep Field. So this image, and I'll show you this is the sort of one narrowed in, just one little chunk of the image. This is what it sort of looks like.
There's so much in that one
Yeah.
image, though.
And
just
here,
like that one little slice.
Yeah, and then the full one. I don't know if I can pull up the full one. I'll pull a big version. Oh, it's gonna make me look at a ping. Oh, I don't want to, but it's gonna. Okay, fine. Here, we'll do this one. All right. So this bigger image has 265,000 galaxies in it. And so,
oh my good
and
golly
so
gosh.
what this is essentially they merged. They didn't actually take any new images. They merged together a bunch of images that were taken by Hubble across these different surveys that they've been doing, and this full image is actually the size of the full moon. So the Hubble Deep Field, Ultra Deep Field, they're actually tiny, about a tenth the size of the full moon. And this one is a much larger, sort of wider survey that they've pulled together. And so, like I said, this one has 265,000 galaxies in it. It's made
That's
of
absolutely crazy.
It's made of 7,500 separate exposures that they have merged together into this one picture. And this is just the beginning. So they're planning a second one shortly. It's going to be another 5,000. And then after that, they're planning on merging all of the observations that are relevant from the Spitzer Space Telescope and the Chandra X-ray Observatory into the same single image to provide this just incredibly deep version of this one chunk of space in preparation for the James Webb Space Telescope. So when James
you said
Webb
the name
launches,
and now you've
I know,
I've
jinxed
another
it.
6 months delay.
Yeah, that's how that works.
But no, okay. So I have so many, just like I'm geeking out right now about how awesome this particular image is. What I want is some awesome like interactive tool to just explore this in some sort of like, I don't know.
You can
not
download
just like I've wandered through the Hubble Deep Field image for like hours at a time,
Yeah.
just like scrolling like minutely, like looking at every little galaxy and at like the merging galaxies and the trios and clusters of galaxies, not really clusters, but it's just like I want some way to get all of the best bits out of this image without, I don't know.
So you can download, the biggest version is a 672 megabyte ping file that is 25,000 by 25,000 pixels. So that's pretty
really
big.
cool.
So you can definitely look around through that. David Dunn is asking, what's the angular size of the image? It's 1 degree.
Half a degree across.
Yeah, the full moon is half a degree. Yeah, so it's a half degree, which is a tiny little portion of the entire
it's tiny
sky.
part of the sky, and there's just so much going on there.
Yeah.
Oh man.
Yeah, it's amazing.
God, I love those images. So when we're done here, I'm gonna spend the rest of the night just exploring this fantastic deep field composite image from Hubble.
Yeah, and you can just imagine the kinds of things, like there are galaxy clusters coming together. You've got galaxies that are in the earliest phases of formation. Some of the galaxies
one's
in
being
there
ripped apart.
go as close to the Big Bang as about 400 million years after the Big Bang, and then everything forward. And so when you think about this image, it's weird to think about what you're looking at. You're looking at this time slice of the universe. The bigger galaxies are closer, and they're also older and more mature, and then the smaller little galaxies that you can see in there are more distant, but also you're seeing them younger in the universe, and you're seeing all these things all at the same time.
But I mean, back when I was at Penn State, we used to spend like a whole day with our intro students just looking at the different types of galaxies you see in the deep field image. And like what you just said, I mean, the smaller fainter ones, they're older in terms that they you know, date from the earlier times in the universe, but physically they're actually very young because they formed, you know, they only had so much time to form. And so one of the things we would do is start looking at the different morphologies of the galaxies, what their shapes and sizes and structures were like in the early universe going forward to the relatively recent universe. And it's so cool to just see sort of the evolution of those different structures going from, you know, faint and fuzzies to sort of elliptical-ish, sort of spiral-ish, and then you get to the nearby universe, you get all sorts of really detailed structures. When you think of a galaxy, the types of galaxies that might be familiar to you, just seeing that progression is really awe-inspiring.
So this is a video that they released where you can zoom in and sort of at the end here. Let me go right to just before the end there. You can see. All right, let's see. Nope. Come on. Let me pause.
Pause right there.
Hold on. Right there. So that's the.
That's the money shot.
That's the level of the structure that you can see, though. I mean, like, look at these galaxies, right? And then, like, these are galaxies. All of these are galaxies. And there's, like, big ones. And you wouldn't see with even, like, fairly large ground-based telescopes, none of this stuff would show up. Like, maybe some of these could be found, but...
Just look at the variety of colors that you see there. Just in that one little snapshot. There's whites, there's blues, there's reds. So cool.
Yeah, I like it a lot. All right, well, Kimberly, let's get into our argument.
All right, arguments. That's not really an argument.
No,
it's us rehashing an argument that some other people are having right now.
It's true.
So you probably remember this. Not too long ago, about a month ago, Vice President Mike Pence decided and announced to the world that NASA was going to put humans on the moon in 5 years. And we all went, what? Excuse me?
Explain how.
What did you say? I think you misspoke there and really meant to say 10 years, right?
Or 20.
Or 20. But nope, they said 5 years, which is 2024. That's their humans to the moon plan. It was announced at one of the National Space Council meetings. It was backed up by the president's proposed budget for NASA for the year 2020. And if you recall, when we talked about this budget, we made a big thing about how the U.S. administration wants more than half of NASA's budget to go towards putting humans on the moon by 2024. It includes shifting a lot of money from pure research dollars over to materials, to infrastructure, to safeties, to the Space Launch System, to the Orion crew capsule, to all sorts of other supporting programs. And you also may recall that I expressed a lot of skepticism when this plan came out, and so did many of my co-hosts, because NASA's existing plan prior to this announcement by the vice president was that humans would be back on the moon, or NASA would put humans back on the moon by 2028. And so you might imagine that a lot of people at NASA in charge of the human spaceflight initiatives were not terribly happy about the abrupt shifting of their timeline. And you would be correct. It's come out recently that a lot of the bureaucrats and higher ups in the scientific divisions really are not on board with the 2024 plan and how it shifts a lot of their timelines and their safety requirements and the regulations that are needed in order to do so. And a lot of flack has come down on the side of the lunar gateway, is my impression. And the general feeling is sort of like, why does this need to happen on this particular timeline? And I should mention, it's not just the people at NASA. A lot of the people, not all of them at NASA, who are not really on board with this abrupt shift, but also a lot of members of Congress as well, on both sides of the aisle, in both chambers of Congress, have expressed skepticism about the 2024 timeline and why it has to be 2024 and why it can't be 2028, like was originally planned. So the next step, or the next part of this argument, was some people at NASA, higher up at NASA, but it's unsure who because they didn't put their name on it, just last week released sort of what I'm calling a promotional brochure in the form of a report. Essentially expressing support for the Lunar Gateway and how it's essential for the plan to put a continued sustainable human presence on the moon and in lunar orbit. And looking through the pamphlet, the report.
Yeah.
It's not
it's
the
5
most
pages. It's pamphlet-esque.
It's pamphlet-esque.
Yeah.
Okay. I no longer feel guilty about using that word.
Yeah.
It's not the most well put together thing. It feels very reactionary in its tone and in its language, and its lots of errors that are in there. And so it exposes this divide between what the administration's priorities are for NASA and what the NASA scientists who are actually working on this project and all of these different separate missions that all go towards this goal, what they think is actually possible and safe and feasible. And what they've said is that, thanks, administration, it's great that you want to give us half of NASA's budget, but in order to actually make this goal and make it a reality, you also need to give us an extra $8 billion a year every year for the next 5 years.
Yeah.
And you need to give that to us up front.
Yes,
so that we can make the purchases, go sign the contracts, make the arrangements, get everything done. If you want this done on this timeline, this is what we need.
Yeah, we are firmly in the middle of the uncomfortable limbo between actually feasibly sending, and by we I mean you, I'm a Canadian, we'll just put an arm on it, but we are in this limbo phase between actually feasibly being able to send a human crewed mission to the moon. On the one hand, the exciting, dramatic, we choose to go to the moon moment, because it's hard and it's going to take the best of everyone to be able to pull off this incredible feat of engineering. On the other hand, you've got this established bureaucracy and politics and pork and established aerospace firms and people who and politicians who have people in all of their states and who vote for them, and there's a lot of jobs, and they're going to look terrible if things don't come together. And shifting from one political landscape to another is excruciating at the best of times, and to do it in such a short timeline is going to be rough. And so
what I understand of this is that the NASA scientists are saying, yes, it is technically possible for us to do so, but not with the resources that you give us and not with the demands and requirements you're making of us. The requirements that include launching using SLS, launching a number of the exploration missions ahead of time, putting the Lunar Gateway in a lunar orbit and not a low Earth orbit, and landing in the South Pole. Those are all quote-unquote required parts of the administration's goal to put humans on the moon.
Right.
And, and under a certain budget.
Yes.
So while the concept is possible to get all of this done in 2024, something has to give.
Yes.
Yeah.
And that's I think the point, right?
They can't do all of that with that budget in that time. And that's what the NASA scientists are saying. And I guess the last part of it is that they can't do it safely in that time with those requirements. If you want to put humans on the moon, if NASA wants to do it, they're going to do it safely.
Yes.
And that's that's the sticking point. That's the hard line that they have, is that the timeline isn't their motivation. The glory of it isn't their motivation. They're going to do it, and they're going to do it right, and they're going to do it safe. And if they can't do it by 2024, NASA's not going to do it.
And I'm sure the enraging part for the people at NASA is they are like a thoroughbred horse that really wants to run. and they have landed people on the moon, and then they have performed all these other things. And a lot of people heap a lot of blame on NASA, which is unfounded, because a lot of it is them having to navigate with the politics, with the laws, literally, that have been laid down by the government. You must build the SLS. You must build the space shuttle. You must build the International Space Station, right? NASA's job is to implement, to the best of their ability, the laws that are being defined by Congress and the Senate and the President. And yet they're being the whiplashed back and forth. We're going to the moon. We're going to Mars. Now we're going to an asteroid. Now we're going back to the moon. Now we're going back to Mars.
This is something that we've brought up many times before, in that to plan a mission and get it to launch and get it to work right and do what you want, it takes, multiple decades to go from the idea to the approval, to the development, to the launch. It's a very long process. And at multiple stages along the way, the mission scientists are required to submit timelines for every little step that they do. And all of those timelines all those steps need to happen at the right time for everything to work. And so it's not like NASA wasn't going to put humans on the moon anyway in the 2020s. They had just planned on 2028. And all of the steps that they needed to complete were all contingent on a 2028 goal and not a 2024 goal. And so I imagine there's also an incredible amount of frustration that all of the preparatory work that went into that all the stuff they've already done and all the things that they already need to do are now going to need to be compressed in order to comply with what's being asked of them.
Yeah, an analogy that I like to think about is like when you look at, say, like the Golden Gate Bridge or the Empire State Building or something, just some incredible feat of human engineering, or like a cathedral hundreds of years ago that took the town 100 years to build. And then you're like, why don't all buildings look like that now? We built one of them, so let's make them all that kind of building. Well, the reality is that to build that one thing the one time required an incredible sort of reaching out and taking risks and building something and focusing all this energy and effort and resources on this one task that once you complete it, then you can't do it another one, right?
Yeah, but
Quickly.
I mean, keep in mind, while you're putting all your time and effort and money and resources into that one thing, you're neglecting so many
all
other
this
things
stuff.
that
Everything's
need to get done.
trade-offs. Yeah, exactly. So so people are always like, well, we went to the moon once and we haven't gone back. Well, yeah, because that's how that works, right?
Yeah,
You do something that's really complicated and difficult, and then you did it, and now
we went to the moon.
Yeah.
We did it by the end of the decade that Kennedy promised, or I guess required, but it also came with a large boost in NASA's budget and resources and personnel and the focus of an entire nation to do that. And what's being asked now isn't being matched by similar boosts to NASA.
So, I mean, this pamphlet on the Gateway, why Gateway, is, I mean, clearly, and without it being undersigned, right? There are some people who were tasked with the future goals of returning humans to near moon orbit with the Space Launch System, and the Deep Space Gateway felt like it was the right machine for the job. That their thinking is that if you are going to go to the moon, keep building the Gateway, because having something that's close to the moon as a jumping off point actually isn't a terrible idea.
Yeah, I mean, the Gateway in and of itself is probably what we're going to need in order to have a regular presence on the moon, to have regular travel back and forth. Something like the Gateway is going to be needed and is going to need to be focused on in order to make this a reality. At the same time, it's completely new. It's completely new technology. It's a completely new part of our plan. I mean, we've gone to and from the moon a few times now, and it was always, there and back. Done. Without any stops in between as a one-off. And so I'm not entirely sure why the heat is coming down on the Gateway itself, because in my opinion, it is the necessary step that we're going to have to take. But if I had to guess, I would say it's because it's a piece of the plan that is new and untested and untried, and also not really developed yet.
Right. Well, when you think about the past, right, you build the gateway, and then you practice getting astronauts tuned from Earth up to the gateway, sending fuel, new supplies. You then send some kind of descent craft from the gateway down to the moon, and over time you've got a fairly dependable, reusable process of getting from
Yeah.
Earth to the gateway, from the gateway to the moon, and like the International Space Station, I mean, here we are at 20 years of continuous habitation in space by astronauts. That is staying in space. And
Yeah.
so that is the going to the moon to stay. But if you throw the gateway out and you just go with
You just have a
building
series of back and forth.
yeah, you put the I don't know, the deep space Crew Dragon on top of the Falcon Heavy, and you launch it to the moon, and the astronauts step out and they collect some samples, they get back in their capsule, and they come back to Earth. You just get a redo of Apollo, and then you just like literally you're like, we used to be able to build cathedrals.
Like we've seen this movie
Yeah,
before.
we've seen this movie. We built a cathedral, and then we built a second cathedral, and yep, we still got it. So, I mean, do you think that this is like, is there a nervousness that the Chinese are on their way to land on the moon?
That's what I hear a lot of people asking, like, why 2024? Because I've said it before, it seems like a very arbitrary number that you pick. Maybe, and when things sound very arbitrary like that, when they don't really have a scientific purpose, the motive is likely political. And the question that I have heard asked most often is it related to the Chinese efforts on the moon? I don't know the answer, because none of that is being spoken of in public.
Yeah, I'm sure the answer is no. Yes,
clearly not.
Yeah.
The other things that I've heard put forth is that it's related to the U.S. political cycle and elections.
What? Oh, let me just do some math here.
What? I don't know. Is 2024 an election year? I don't even know.
No, but hold on. So let's see. We've got the next one is 2020, right?
Yes.
And then 4 years.
Math.
Interesting
math.
I
can't
math.
do that math.
No.
It's too hard for me.
Yeah.
So I mean, I've heard a lot of theories about why the timeline is what it is. At this point, the timeline itself is one of the many pressure valves that could be released. It's one of the many things that could end up changing in order to make this goal, but not exactly how it was originally put forth. There's the maybe not 2024, maybe let's do all of this, but at 2028. There's the give us a lot of extra money, which isn't likely to happen. There is the how about we don't use SLS, but instead we use
Falcon Heavy,
SpaceX, Falcon Heavy, something like that. There is the let's not have the gateway in lunar orbit, but in low Earth orbit instead, which it probably won't be what ends up happening, just because, otherwise it's not really a lunar gateway. Maybe a low Earth orbit gateway to the moon.
I believe we have one of those.
I think we do.
It's an international station
something
in space. Yeah.
Gateway.
Yeah.
Right.
So what do you think though? Do you think we're going to see this? Like, we're going to see a resolution soon? Something's got to give. Like,
something has to give, and it sort of have to give. It sort of has to give soon.
Yeah.
I mean, we're almost. It's weird to think of it, but we're almost halfway through 2019.
Yeah.
We're at the 4.5 year. Almost for this goal. The 2024 deadline is almost certainly going to not actually be 2024. I think that's pretty much certain at this point.
Yeah.
If only we only had to look at the history of many NASA launches to realize that 2024 probably isn't a firm deadline.
But what gets thrown out? Which babies get thrown out of which bathwater as there is a rush to push for this 2024? Do we lose SLS?
So I think we lose a lot of the softer goals. And I consider, for example, the requirement to land in the South Pole of the moon. I would consider a soft requirement.
Right.
Because there are certainly many other research-worthy regions of the moon to look at that we haven't looked at before. That may be easier for the gateway to access than the South Pole. So maybe that's one of the things that gives. Maybe NASA's budget does undergo a bit of a shift towards prioritizing moon travel as opposed to pure research, but probably not to the degree that was requested by the administration. Maybe that's something that happens as well. I think at this point, Space Launch System is going to have to launch at some point.
Mm-hmm.
Whether it's ready for this or not, I
To do what?
don't know.
Yeah,
To
carry
do the
what?
one thing.
So
yeah.
I mean, it really.
So at this point, maybe SLS only launches one of the exploration missions as opposed to
Mhm.
a crew capsule.
Yeah. At a,
Maybe it only does that.
but you? I mean, it is a place. I mean, it gobbles money,
It does.
and so, and you can't run SLS at its rate of gobbling money, and also come up with a different architecture to send humans to the moon.
yeah.
And canceling
and
mess would be a political train wreck.
Yep, you can't cancel it. You can't
Use it.
prioritize it. You can't really use it for what we're asking for, and it's not reusable,
Right.
which is one of the biggest goals, is to make this reusable and sustainable. And that's not SLS.
All right, place your bets.
2027.
You think that there will be a return mission to the moon by 2027 carried out by NASA?
Yeah. Because I'm an optimist like
You
that.
really are.
Yeah, I would have said 2029, but I was like, no, I'm feeling good today. I'll say 2027. Feeling positive. Now, about the rest of the goals, I have no idea, but I would very much be surprised if SLS ends up being a large part of the end goal.
think we get the Deep Space Gateway.
Sure.
And
I
yeah.
would love to see that, see the gateway.
And
Let's
then,
do it.
Yeah, and so I think
But I want the gateway as it needs to be done
For
in
sure.
lunar orbit, as it was originally designed in order
it'll
to
be
make
in cislunar space, not in lunar orbit. But I can't imagine, like, the SLS is the machine that will build the gateway. Parts of various SLSs are in place already. That continues on. The gateway gets built, and the sort of long-term goal is that maybe once humans are up on the moon, they're going to consider they're going to start sending robotic rovers from the gateway down to the moon and returning them back to the station, and they will send people there. My guess is the first American will set foot on the moon 2032.
Ooh.
Yeah.
Okay.
After
I will add this.
SpaceX and after the Chinese. But both of those will be stunts. So they won't be there to stay in the way that the Americans will be proceeding forward. That's my
Slow and steady wins the race.
That's my guess.
Okay.
Yeah.
I'm going to add this to the list of space wagers that you and I have going right now.
We have a bunch
we have
now?
a couple going on.
Yeah, all right.
Yeah.
I don't even remember how many crazy wagers I've been
Yeah. Well, I
gotten
can think
into.
of at least two others that you and I have made, mostly involving when we're going to detect life.
Oh, and when we're going to detect
Yeah.
another Earth. Well, I've since
Detect another
learned
Earth, detect a life, and where we're going to detect life. Don't forget.
Right. Okay.
Yeah.
I forget
add this to
what
the
I
list.
said. Okay, great. Someone's got to keep track of this. 'Cause
It's on
I-
record somewhere.
I sure don't. Yeah, I'm sure it's in one of our shows. All right, we've got like 1 minute left. I want to go through two quick pieces of news. I'll do one first,
Yeah.
and then you can. I think you had one last little story, right?
Yeah, it's a little one.
Okay. All right. So astronomers have found potentially have figured out that the gold, uranium, iodine, and a bunch of other elements that you've got in your body right now probably came from two neutron stars that collided in our neighborhood about 100 million years ago. And they guessed that you've got about an eyelash's mass of neutron star in you right now, mostly from the iodine that was created during this explosion.
That's so cool.
Yeah.
That's a very precise measurement.
Yeah.
One
yeah.
eyelash worth.
One eyelash's worth of colliding neutron star that fed into the formation of the Earth. So that was the That's it. That's a quick story. What's yours?
So my quick story is about the dwarf planet Haumea, which you may recall 2 years ago was discovered to maybe possibly have a ring in orbit around it, in addition to its 2 moons. And a recent computational study was looking more closely at all the ring particles to try and figure out what the heck kind of orbits they're in and how the heck they can be in stable orbits around such a tiny little object with already 2 moons. And what's really interesting is that these rings are not in a stable gravitational resonance like you might think, something that could add a bit of extra stability to tiny particles in orbit around a tiny object that doesn't have a lot of gravity to work with. But instead, what these particles probably are, they're probably in a very tight circular orbit, in a sort of in a family of periodic orbits, as opposed to a particular gravitational resonance. So none of this is actually observable using a
Right. They ran
telescope because this thing
simulations.
is so dim and so far away. This is just going over old data of the original detection of the rings, running it through a computer to see how this tiny little football shaped piece of rock in space could actually host a stable ring.
Awesome. All right. Give us a shameless self-promotion for something that you're working on.
Ooh, shameless self-promotion. So I was just working on, what was I working on this week? Oh, I was working on a really awesome story about the Psyche mission and a student intern program they have to create artwork inspired by the metal asteroid Psyche, which is just so cool.
That's cool.
These undergraduate students are just, they have this like the best imaginations coming up with all sorts of paintings and sculptures and jewelry and light shows and original music and videos, all inspired by the mission to the metal asteroid Psyche. So super exciting. You can read that on eas.org this week. And then I've been looking into the Apollo missions and all of the amazing moon samples that
It's a good year for it.
It's the year for Apollo, don't you know?
Yeah.
And we brought back so many kilograms of Earth of moon rocks back to Earth, and what sorts of amazing discoveries about the moon that those samples have given us. So that's awesome.
Very cool. I think I did a video this week on my YouTube channel, but I don't even remember. Oh, that's right. 3D construction in space. So I did a video about building this company called Tethers Unlimited builds is got this gadget called Spider Fab that they want to launch that will build trusses, 3D printed plastic trusses in space. And
like you print them in space?
You print them in space, yeah. So the thing just sort of
Ooh.
spews out a truss, and then it sort of clips it off, and then attaches it to another truss, and it can build structures. And so one satellite, one launch, it's 2 cubic meters of volume for 1,500 kilograms, will build a 300-meter radio dish in space. It'll build an Arecibo in space.
That sounds like a really interesting solution to the problem of having large telescopes in space and getting them up there safely.
Yes, exactly. When you think about, for example, a $9 billion telescope that it has to unfold,
that's the size of a tennis court,
and
maybe?
Every single hinge has to go perfectly, or the
and you
whole
don't want to
thing
drop
is
another
lost.
bolt in there.
Yeah.
Yeah.
What if you just launched these things and had them build in space? It was absolutely fascinating. I'm really excited about the technology. So I know people are like, "Oh, Fraser loves LUVOIR and LSST." Well, let's just add 3D space construction. There's 2 companies really doing it.
3D space construction.
Yeah, there's Tethers Unlimited and Made in Space, and both have some really exciting ideas that I like. So, all right, let's move on. We were like a couple of minutes late. Sorry, everybody. Thanks, everyone, for watching us. Thanks to our special guests. Thanks to the moderators. Thanks to our good friends of the Weekly Space Hangout crew, wshcrew.space. And, of course, thanks to my co-host.
That's
and
me.
We will see you all next week. Bye. How do I stop this thing? There we go.